So I just want to talk about end behavior super quick. And so we're in 3.10, and you're just going to take everything that you've learned and you're going to be able to write equations, and you'll be able to tell features of a graph. So here goes this one right here. Well, actually, let's look at a picture. So this literally says, I'll type it out. In this line literally says, as x, well, as you travel left, meaning negative infinity, right? They're asking you what is happening to y. So then you like go anywhere on the graph and just start going left. So as I go left, I'm going up. What number is that? Right? So that's just infinity. So I just write an infinity symbol there, right? And then this one says, instead of saying as you travel left, this one's saying as you travel to the right, right? So as I travel right, where am I headed? And everyone says, oh, positive infinity again. Very good. So this is what end behavior is. End behavior is simply like as you go all the way to the right, where's y going? And you're like, up. Good. That number we say is infinity. As we go all the way left, where are we going? Up. And we would say positive infinity. Okay. So really quickly, let me show you this one really quick. Let's look at this one. So this one, I pull over a graph from Desmos and I would graph it. Right. So I go 2 parentheses, x minus 1, close open, x plus 3, quantity squared, right? So I'm going to look at this graph and I'm going to ask you the same questions. As I go to the right, now some of you can't see down here, so pretend I follow all the way down and I jump back on and I'm traveling all the way right. Where am I headed towards? Yeah, infinity. Good. And as I travel left, where am I headed towards? Yeah, not infinity. What is this guy called down here? Yeah, negative infinity. Very good. So you can make assumptions, okay? Make the assumption that when you can't see the graph anymore, it's going to continue the way you think it should. It's not going to do some weird thing like, right? It's not going to do that because you can't see it. So as it exits the window in which you see, you could assume that it is doing what you expect it to do. So for this one, because it went like this, right? Actually, sorry, let me grab that so that you guys can all see. So as it goes off, this first one is going to be positive infinity. Oh, sorry. As it travels, this one says, as it travels to the left, it went negative infinity. And as it travels to the right, it's positive infinity. Some people like to put the positive there. I don't, because we don't put positive 4. We just write 4. Okay. I'm going to go through each of these so that you guys all remember. Most of these here are things that you've already seen. Okay. So this is end behavior. We're just putting infinity or negative infinity. You're just telling me what happens at the very end. Some of you are so good at this that you can look at this and be like, oh, it makes sense for the right side to end positively and the left side to end negatively, right? That makes sense. So the other thing that I want to talk about is roots with multiplicity. Roots with multiplicity are any root that doesn't go through the x-axis. It looks as if it's a quadratic, a cubic, a quartic, or whatever. So do you all see how this looks like a little mini parabola right here? Does everybody see that? So we would use the language that we have a root with multiplicity of -3. So we'd say -3 with multiplicity 2. Does everybody understand why I'd write -3? You're like, yeah, that's the root. Okay, why would you write multiplicity 2, Miss Johnson? Because it kind of looks like a quadratic, and quadratics means squared. Does that make sense? Does this one have a multiplicity? Do you guys think this one has a multiplicity? No. So I'm just going to write the root of 1. So I have 2 roots. I technically have 3. I have -3 with multiplicity 2, so he counts twice, so 1, 2, and then I have a 1. Should I have been looking for 3 roots? Can you guys look at this and tell me, should I have been looking for 3 roots? Everyone says, yeah, Miss Johnson, because look, x times x squared is x cubed. Yay, good, fundamental theorem of algebra. Okay, lastly, the value of the leading coefficient. The value of your leading coefficient is just the number all the way out in front. That's a 2. Okay, the fact that this 2 is positive means that it ends the way you want. Now, watch what happens when I make this guy negative. Everybody, don't blink. Ready? Well, actually, sorry. Let me just copy this. What happens? No, I'll ask you. What do you think happens when I make this guy negative out in front? What do you think happens? Yeah, he flips, right? Let me turn red off really quick. He flips. So on the right-hand side, where is he headed? And on the left-hand side, where is he headed? So this A, we call him A, this leading coefficient, he is in charge of telling us how to end. That's his job. That's always been his job. You've known that, but we've never put it in these terms, okay? So that is what end behavior is in a nutshell. All right.